On June 3rd, 2026, Google DeepMind released Gemma 4.12b, a new open-weights AI model. It can work with text, images, and audio, and it's small enough to run on a regular laptop with no internet connection. In this video, I'll cover what it is, where it fits among Google's other models, and the main technical idea behind it, how it performs, and how you can try it yourself. Let's start with the basics. Gemma 4 is Google's family of open models. Open meaning you can download the actual model weights and run them on your own hardware, rather than calling an API in the cloud. The 12b refers to 12 billion parameters, which is a medium-sized by today's standards. It's released under the Apache 2.0 license, so it can be used commercially. And according to Google, the Gemma 4 family has now passed 150 million downloads. In Google's current lineup, this model sits in the middle. Below it is a standard model called E4b, built for phones and edge devices. Above it is a larger 26 billion parameter model that uses a mixture of experts' design. Gemma 4.12b is meant to bridge those two, more capable than the edge model, but light enough to run locally. Google says it needs about 16 gigabytes of memory, which covers many modern laptops, including Apple's Silicon Macs. It's also the first mid-sized Gemma model that can take audio directly as input alongside text and images. Now, the main technical idea, which is what makes this release notable, to understand it, you need to know how multimodal models usually work. A multimodal model is one that handles more than just text. Normally, to let a language model see an image or hear audio, you attach a separate component called an encoder. The encoder is its own trained network, whose job is to translate pixels or sound into a form the language model can understand. Most multimodal models have a vision encoder and an audio encoder bolted onto the side. Gemma 4.12b removes them. Google calls this an encoder-free or unified architecture. Instead of a large vision encoder, it uses a much smaller embedding module. Reports put the vision encoder it replaces at around 550 million parameters, and the new module at about 35 million. The way it works, an image is cut into small patches, each 48 by 48 pixels, and each patch is converted into the model's internal format by a single mathematical operation, with its position added separately. There's no heavy network in between. For audio, the encoder is removed entirely. The raw sound wave, sampled at 16 kilohertz, is sliced into 40 millisecond chunks and fed almost directly into the model, in the same format as text. So the model, text, image, and audio all become the same kind of input flowing through one network. Why does this matter? 3 practical effects. First, fewer parameters spent on encoders means less memory, which is part of how it fits on a laptop. Second, the model can begin processing immediately rather than waiting for a separate encoder to finish, which reduces the delay. And third, because all the inputs share the same weights, fine-tuning the model is simpler. There aren't separate components to tune. It's worth noting this encoder-free approach isn't entirely new in research. Earlier models like View and Eve explored feeding image data straight into a language model. Gemma 4.12b is a larger mainstream application of the idea. Now, performance. Google says the 12b model performs near its larger 26 billion parameter model on standard benchmarks and beats the older Gemma 3.27b on tests for reasoning, knowledge, and document understanding. One caveat worth stating clearly, these are comparisons within Google's own family of models, and Google did not publish a full table of benchmark numbers at launch. Some specific scores are circulating in the community, but they aren't officially confirmed. Compared to models from other labs, coverage suggests some, like DeepSeek's larger models, are stronger overall, but require data center hardware. Gemma 412b distinct position is running well on a consumer machine. A couple of other features. It ships with something called the multi-token prediction drafter, a small helper model that speeds up text generation without changing the output. A secondary report lists a context window of 256,000 tokens, meaning you can take in a large amount of text at once. If you want to try it, the weights are available on Hugging Face and Kaggle. You can run it through tools like Ollama, LM Studio, and llama.cpp, or Google's own AI Edge apps, which demonstrate things like transcribing and translating speech entirely offline. For deployment, it's available on Google Cloud. So to summarize, Gemma 412b is an open, multimodal model, small enough to run locally, and its defining feature is the encoder-free design that lets it process text, images, and audio through a single unified network. Thank you for your attention. Peace.